Problem. You need to move items from point A to point B inside your warehouse, and you've hired a bunch of very expensive and very human warehouse workers, and are therefore very incompetent. Introducing our solution, Hammerhead, the autonomous warehouse worker solution, which is completely free from error, cannot unionize, and requires no salary, but only a one-time fee. We've ensured that our product can fit within a 15 by 15 by 15 centimeter cube, is under $185, and can attain items at 3 different shelf heights.
Hi, I'm John. I'm responsible for the mobility system of Hammerhead. To get our system to move around, we decided to go with 2 parallel tracks that were both powered by 2 100:1 micrometal motors. Each motor was driven by a motor hat that would feed each motor a different PWM signal. This would enable the robot to travel at different velocities and to rotate on the spot. This was all facilitated via feeding the motor driver hat with power from the battery through a PCB of our own design, which would cut down on wiring. Overall, this robot is able to travel at a minimum speed of 20 millimeters per second, to travel up a 15-degree incline with a kilo of load, and to make precise movements that enable robust and accurate item collection.
Speaking of item collection, hi, I'm Alex Jones and I was responsible for Hammerhead's item collection system. Inspired by front-loader diggers, the team decided an angular lifting mechanism was the fastest and most reliable of our prototypes to implement. Each arm consists of 2 acrylic struts, allowing the gripper to stay horizontal no matter the elevation. To move these, a single 4.6 kilo metal gear servo was mounted at the top of the robot using a 3D printed component. Also, a torsion spring was used to counter part of the gripper's weight, easing pressure off the motor. To ensure an equal force distribution across both main arms, the servo connected to a third central arm which did all the heavy lifting. Using this hardware and the software libraries GPIO0 and PyGPIO, the result was a smooth lifting mechanism. Connected via hinge to the end of each arm is the gripper. The 3D printed claws were designed to bend, allowing it to hold items tightly. Both claws are bound between 2 acrylic plates, but while one was bolted tight, the other slid along the acrylic's length. A 30:1 gear motor is secured to the stable claw with a lead screw and specially machined nut connecting to the sliding claw. Working together, the arms and gripper provide Hammerhead with a robust item collection system.
Hey, I'm Luke and I was in charge of vision for our robot. In order to accomplish any of its tasks autonomously, our robot has to see. This is where the need for computer vision comes in. We mounted a Raspberry Pi camera module to the end of the robot's arm, which continuously records images of its environment and feeds them into the Raspberry Pi. For processing these images, we use a Python module called OpenCV. With this library, it allows us to use color thresholding and contouring to isolate and identify regions of interest in an image. From this we can extract useful information about them, such as size and bearing, which can then be used to calculate how far away from certain objects we are, and allow navigation around the warehouse.
For the navigation, it was actually a team effort between Alex, Luke and myself. This navigation system has a lot of logic, but at its core has a lot of simple functionality. For instance, we use a lot of proportionality to control our car to get from A to B. And we use distances to get the robot to rationalize how far it needs to be in an aisle to get to a certain bay. Or how we navigate up the ramp, whereby we get the servo to lift the arm up, which has the camera on top, to get the camera to look at the top of the very corner of the wall and let the camera navigate the robot towards the wall until it hits a certain point whereby the camera can't see the wall anymore and therefore it drops the item. And we've done all this whilst reducing timers as much as we could to make sure that the robot was based in the real world rather than guessing. Consider purchasing the product with the QR code below. Thank you for your time and cheers.